Let's go inside.
Sure. My name is Daryl Cove. I'm a senior hardware engineer. I've been here for 32 years. So I've seen projects from long ago, simple 1 gig boxes, the simplest of switches, to what we just released to the world last quarter, which is one of the most complex switches in the company. Right? There could be a mechanical issue, which then I would investigate and guide towards the mechanical folks. Now, there's also this device right here, which is called an oscilloscope, very high-end, very expensive. We have quite a few of these because it's necessary. If I have to look at something that might be signal integrity, a signal integrity issue, I need to have equipment that can show me that. And if we have to alter termination or what have you, that's generally done in the early stages. There are 3 stages to our development, right? There's proto, initial conception. Then there's beta, which means anything we found in proto we didn't like, we incorporated in beta. And then we go to what's called pilot. Pilot is a first phase of manufacturing. We go through that pilot process to make sure the whole process is perfect before we go to the general availability to the customer. But where we are here, this is our environmental section of our testing. So I just mentioned proto, beta, pilot. When we get into beta, now we're interested in can these units work under the full scope of our temperature qualification, which is -5C in the case of that unit I just showed, up to 45C. And that includes it's full of optics. There's a lot of heat dissipation. There's a lot going on. So what we use thermal chambers. And we can monitor these from our bench. We have consoles and direct the temperature. And we're looking at consoles at the system itself to see if there's any anomalies. And these are all programmable. So this would be a good example of a system that's in the thermal chamber and is all connected and will run for days. And this is the kind of qualification we do in parallel, I'll say, with our manufacturers doing the exact same tests that we are to make sure we're all on the same page before we get into GA. So this is our test in manufacturing engineering area. If they get, say, a component, let's say a connector, and they seem to be having trouble with it in manufacturing and we don't understand it, well, there's some very high-end equipment over here that we can take a look at. Take a look at these devices under there. There's microscopes that are very high, very, very high powered. This microscope, as you can see, was just in a position where they're looking at a very specific connector or connectors of this type, where maybe someone in manufacturing put a device in here and it bent a pin. Why did it bend a pin? Well, we're going to dive in and we're going to find out in parallel with the manufacturer. We're always working as a team. And if it's something that's very deep in the board, like solder contacts and what have you, where the device is sitting on top of the solder contacts, you can't see the solder contact unless you're incorporating a high-end X-ray machine that will look through all of the components in the PCBs and go down and dig and show you those solder contacts. So it's very high-end, but it's necessary in order to maintain the quality we like to maintain. I think they would have to know that when we're providing them with a piece of equipment, the quality is first, right? Number one, quality, make sure there's no issues, and we beat these machines to death to make sure. Now, we have many test processes, and they're deep and they're long, but it all comes down to a product that rates A+, A++ to the customer.
I'm Al Jackson. I'm a G-Tech lab manager for the Salem group. We work in the fabric engine side of the world. Been here for 30 plus years. We actually support everywhere across the world for this lab here. There's a couple of smaller labs, one in Reading, one in Chennai, and we have one out in Japan, another lab. So the guys that I have been dealing with, on average, you're talking 25, 30 years of support just in the fabric world. There's some much smarter people than me in the world that work with that stuff. They are brainiacs. They are the best of the best. The guys you get called in when they get called in for the SMEs. But for me, my goal is basically to make sure that SME can solve that problem as fast as they can within a reasonable time frame. But most of the escalations when they come in, it's usually a pretty fast turnaround about getting an idea what the problem is. 9 times out of 10, the SME will have an idea what's going on with where he wants to look. Load configs, getting the right revs on, getting all the correct optics. That's the hard part, is finding all the little onesie-twosie optics that are in the world. But for the most part, when they get it, it's usually, you're looking at about a week, get an idea where they have a little understanding of what's going on.
All right, well, my name is Ken Jones. I'm the Manager of Solutions Engineering here at Extreme Networks. The goal of Solutions Engineering is to work with the SEs out in the field, the customers out in the field, and our development team who are actually making our products. So we'll have a solution pre-built for them. They can teach people about that solution and utilize this equipment, and it's all ready to go. So instead of us having to haul equipment to a customer location for like a proof of concept or something like that, we can build that entire proof of concept here, and they can all access it remotely. And we help them out with that. Plus, our product experts that, work with us, that will work with those people that are on site and make sure that what we're providing for them, it fits the solution that they need. I have another section of it that I'm not going to show you that's outside of that door, is where all the client traffic is actually produced, which is basically tons and tons of real laptops, a lot of VMware information and whatnot that are just basically mimicking real traffic that happens on real enterprise networks.
All right, Ben, thank you so much for joining.
Not a problem. Thank you for having me.